Scan your pencil from left to right along the x-axis. Fill in that blank for me. Scan your pencil from left to right along the x-axis. For the range, scan your pencil from bottom, write this in, to top along the y-axis. All right, so domain is left to right along the x-axis. What are the possible x values? The range is bottom to top. What are the possible y values? Let's look at number 1 on your paper there. Here's number 1. I blew it up here. What's a domain? What's the range? Let's see. So this is kind of this is what we call an absolute value function. You're gonna see this when you guys are more in Math 3. Garcia, you remember this, I think, right from Math 3. Look at, what does that arrow mean? Forever and ever and ever and ever. Look at that. And same thing over here. Forever and ever and ever that way. So what are the possible x values for this function? Well, let's see. I'm going to scan my pencil from left to right. From here, I'm going to just scan my pencil. I'm just going right here. I'm looking wherever I put my pencil on the x-axis. Look at, there's points on the function. If I go right here, there's a point right here, right here. So I can see that no matter where I am on the x-axis, even if I come over here, if I'm right here on the x-axis, there's going to be a point up here. X can be any number here for this function. It's not like the thug running away from the cop. X can be any number, so the domain here would be all real numbers. We're going to write all real numbers. A real number is just a number that's on the number line. So this one goes on forever. This function goes on forever that way and forever to the right. That means X can be any number, so the domain here would be all real numbers. The cool thing about all real numbers is there's a symbol. Instead of writing all real numbers, from now on, go and write a double bar that looks like an R. This means all real numbers. It's a fancy schmancy symbol that means all real numbers. So from now on, just write this if you want to write all real numbers. That's good. How about the range? So Ms. Garcia has already seen something that the range, look at, from bottom to top. I scan my pencil from bottom to top. I notice that the function is not defined below -2. Like all these values, the function doesn't exist for y values. It starts kicking in right here at -2. Excellent. Can y be anything at -1? Yeah, look at y can be here and here. Can y be a 0? Yeah, okay, right here and here. Can y be 1? Yep, right here and right here. Can y be 2? Yeah, right here and right here. Notice how I'm thinking about the possible y values.
So it's -2 is less than or equal to y?
Well, let's first state y. So y is going to be equal to 2, or actually -2, right? So here's -2. Y can only be numbers that are -2 and bigger, right? Nothing below -2. So the way I would write that is y is greater than, because look at -1 is bigger than -2, 0 is still greater than -2, 1 is still greater than -2. So all these values are greater than -2 or equal. There's our range. So greater than is whatever the Pac-Man wants to eat is whatever is greater. So think of the mouth. That's the way I memorized when I was your age, the Pac-Man. The mouth wants to eat what's bigger. So the way I would read this is y is greater than or equal to -2. That's the range. That's the possible y values that exist for this function. Let's try number 2. The more you do this, the more you'll get the hang of it. Right now, what I need you to focus on is that domain describes x values that are possible, and range describes y values that are possible. Let's try number 2. Question number 1 before I move on, though. I'm getting sort of a deer in the headlights look from some of you. Toscano, I hope you didn't give up on me. You're the man. How about you, Franco? You're the man. Watch this. We've got a circle. What are the possible x values for a circle? Let's see. So for domain, scan your pencil from left to right. So right here, there's no function, no function, no function, and the function kicks in for x right here at -3. The function for x here, yeah, look at, there's some, if x is -2, here's your function right there. If x is -1, here's your function right here. Look at it. So x kicks in here and stops right there. Right, for x. So let me describe the domain now. Here we go. X then has to be bigger or equal to what, Miss Garcia? Thank you. Look at bigger than or equal to -3. Look at that. But not only that, it's got to be less than or equal to +3. Look at that, you guys. X can be any numbers in between -3 and +3. That's for domain. It's time for range. So the range is your y values. You go from bottom to top.
It's the same thing.
I think so. Look at y's kick in from here and stop there. That's your possible y values. So y then, watch, is greater than or equal to -3. Because look at, that's the lowest possible y value, that -3 on the y-axis. The highest possible value is +3. So that means y can be less than or equal to +3. Rockin' and rolling. Or rolling and rocking. Which one is it? I forget. Question number 2. Oh man, this coffee's good. Woo! That's a good cup right there. Any question on number 2? Number 3, let's do it. Someone besides Garcia, what do the arrows mean again? Infinite. It never stops. When you have infinite functions, those are pretty easy because that it's kind of communicating. Look, x can be any number you can think of on the number line. So the domain here is all real numbers. Look at, you think of an x value, it'll be on this function. Any x value. Toscano, what's your favorite number? Look at 1, 2, 3, 4, 5, 6, 7's right here. Look at Toscano's number would have a value at the function, so it's 7 something here. Rivetta, what's your favorite number?
7.
Boo! Give me something more interesting.
42.
So look at 42 would be way out here, way the heck out here, and the y value would be down there somewhere because it's going on forever. The point is, I know, it's all right. The point is, x can be any number in the universe, therefore it's all real numbers. Any number on the number line. Quick, go ahead. All right, that's domain. Let's do range. From bottom to top, I'm looking at the y-axis now. All real numbers also. Look at that. Y can be any number also, so it'd be all real numbers. Excellent, Garcia. I trust it's starting to become a little bit clear. Or no? I know Garcia's seen this before, so that's cool. Ivanovic, I think summer school I went over a little bit. Maybe, I'm not sure. Let's try number 4.
Oh Lord.
It's going to be okay. Here's a math 2 function that you'll see when you're in math 2, or you should have seen when you're in math 2. We call this a quadratic function. It's a parabola. All right. Notice the arrows, infinite this way, infinite that way, and it gets wider and wider. Infinitely wider. So from left to right on my x-axis, what are my possible x values?
Oh.
All reals. All right. From bottom to top now, look at the y-axis.
4 is greater than or equal to, or less than, 4 is greater than or equal to y. Or y.
So let's start off with what we're describing in range.
4.
4.
Well, we're describing y, huh? Start with y. So y has to be what, Garcia? Finish it for me.
Greater than or equal
To 4?
to? Is it less than or equal to?
Well, the maximum is right here, huh? So y can't be bigger than 4. It's got to be
Equal to or less than?
less than. So let me change the Pac-Man. Less than or equal to, we're rocking and rolling.
Alright.
2 more quick ones and we're done. You do a small pair share. Hang tight. That's true. I forgot that. Shame on me for forgetting. Hold up though. Let's do 5 and 6 together real quick, Franco. Here we go.
Oh, Lord.
You keep bringing God into this conversation. Here we go. Domain. What variable are we describing for domain? What variable? X. I just start off with X. Here we go. X can be anything here, between here and here.
Less than or equal to.
Careful. X has to be -1,
Okay.
bigger than it, or equal to -1. Look at these. All these values are bigger and equal to -1, and it stops here. It maxes out at 5. Huh? X has to be less than or equal to 5. Notice that. There's my domain. Range, let's go from bottom to top. The bottommost y value is here. The topmost y value maxes out right here. So I'm describing this for my range. Huh? So y, I described y when I described range.
Less than or equal to -3 and less than or equal to 3.
One more time.
So it's less than or equal to -3.
Careful. Not less than
3 less than.
Because look at if y is less than -3, it can be these values. These are all
Yeah. It's greater than or equal to -3.
right. It's got to be greater or equal to this value, that's -3, the smallest value, and less than or equal to the maximum.
Me too. It's just the sign that
It's because
We got to get those signs right. So let's park our car there. Let's park our car there. 1, 2, 3.
So you read it, when you read it, you start out y. Y is
Yes.
greater than or equal to -3. Okay.
And less than or equal to 3. Perfectly said. Perfectly said.
But how
Sorry. One more time.
Those symbols are the same.
She's talking. One more time.
yeah.
Those two symbols are the same. How does it that
These
one
two?
mean less than and that one means
Because it's like I would read it, it would be -3 is greater than
One at a time. Let's talk one at a time.
That's what you
Let's talk one at a time. Let's talk at one at a time. So,
Those symbols are confusing.
they're the same, right? They're the same, right? Okay, here's what we're going to do. Watch this. Stay with me. Let me draw Pac-Man. This game was better than Fortnite in the day. Stop laughing. Watch this.
That's sad.
All right, watch this. This may clear it up, Palomatis. Because I know some of you are thinking the same way as Palomatis is thinking, what the heck is up with these signs? Watch. It's fun, my artistry. Watch this. Why? Look at it. The Pac-Man always, here's a rule of thumb. The Pac-Man always wants to eat what's greater. Okay? He wants the more food. That's pretty easy to remember, right?
Hey, what?
Pac-Man always wants to eat whatever's greater.
Okay.
The greater amount of food.
Alright.
So which one's greater here according to this? The Y or the 2?
y.
The Y is greater. So I'll read this as Y is greater than 2. Or I can read it from left to right. 2 is less than Y. It means the same thing. It means the same thing. I've said the same thing. If I say 2 is less than Y or Y is greater than 2, it means the same truth. Logically. How about this? Read this 2 ways, somebody.
X is greater than 10.
Or, now read the second way.
10 is less than x.
10 is less than X. You see, it means the same thing. It means the same thing. So now back over here, back at the ranch.
That confuses me more.
Darn it. I thought it cleared up. I don't want to hear that.
No, because I still don't get the equation.
Let's go back a minute now. Let's go back. Let's go back. Let's go back. All right. You want me to try explaining? Let's see. Maybe he'll explain it better than me. Let the guy talk. Go ahead. Hit it.
With the back of the Pac-Man, the little where the V end is facing different. Both of them are facing different things. That one is facing -3, and that one is facing Y. They're in the same direction, but they're facing different numbers. Different. Like that one's facing Y, and that one's facing different things.
Or another way to put it is, I'm saying two things at one time here. I'm saying, look, and I'm saying this
Well, why
part.
are the symbols the same?
Well, here's why. Look at this. I'm covering this part of my hand. So look at this statement right here that's not covered. Here I'm saying, look, x can be greater than, right, there's a fact, x is greater than or equal to -1. Look at, there's -1. Let me talk, gentlemen, over here, please. Thank you. So here's -1. X can be bigger than or equal to it. So look at all these values are bigger than -1. But it doesn't stop there. It maxes out at 5. So look at the other side is this now. I'm going to cover this part. X can also be less than or equal to 5. Look at all these values are less than or equal to 5. It can't be bigger than 5. So when I describe the domain, I'm describing what X can be. X can be two things at one time. It can be bigger than that lowest value or lower than the highest value. Now I said a lot there. The more practice, the more fluent you'll get. Just stick with me though. I think I saw it on the hand or some other question.
I understand.
Are you sure?
Yes.
Positive. Put down everything.
Well,
Okay, never mind. All right, so watch this. Y has to be bigger than -3. Look at, all these are bigger, but less than 3. All these are less than 3. It maxes out here, bottoms out right there. It's maximum and minimum. Let's try one more. You'll get the hang of it, trust. Which one? 6? You sure?
no.
Is she right?
No.
Yeah, doesn't it? No.
Wait,
No.
No, it doesn't.
All reals for the domain?
X is all real. Y isn't.
No,
You're trying to confuse us on purpose, aren't
You're
you?
right. I think X is all real numbers. Y isn't.
I don't know because I think they both are.
I think Garcia's got this one.
Really?
Watch. Arrows mean infinite. Look at this, goes on forever that way. This goes on forever that way. So x, if any x value you pick, there'll be some y value on that function.
What?
Whatever you said.
Wait,
You're
question,
losing us.
question.
Yeah.
Well, what is that little line right there? Why is it, it looks like it
No,
stops
you
from
read
that
it left
section.
to
That
right.
section of
You
Y.
read it left to
Let's
right.
go one at a time. Well,
That section of Y looks blocked out, blocked out to me.
Where's blocked out? Come over here. Where's the blocked
I'm
out?
not like that, but like,
Talk to me.
It's
Talk
not
to me.
a word.
Talk to me, Rivera.
Left to right.
Talk
I'm
to
just
me.
saying, like,
Talk to me.
So that
Wouldn't
means
this
it-
be considered a point? Like right there?
No.
Because of the other ones, that's what you did.
Wait, what? Talk about what?
Okay, what you did is last time, right? You said, wait, can I?
Sure.
Right? Okay, wait, not that one. That one's right. Like this one, right?
Right.
You hit there.
It stopped, right?
Huh?
Okay, you hit it
Same thing
left.
here. What do you mean to stop right here?
Okay, that's a beautiful question. Look at that.
Stop.
Okay, that's a beautiful question. Look at it. He's saying, doesn't it max out here? And the answer is no. Here's why. The function, Rivera, the function goes higher than that maximum value way over here. Look at the function right here.
oh.
So in math, they call that what they call a local maximum. Local.
How do you remember all this? That's my question.
This is talking.
That's it right there.
That's the answer.
Follow
Talking is a little scooter.
Coffee is the answer to all of life's problems. Just throw coffee at it.
Yeah.
So Rivera, what's the domain?
All real numbers.
Hit it. All real numbers. Write that in there.
Number 7 is hard.
Hold up, hold
I
up.
thought this was the last thing. That's what I heard. I'm not complaining.
Give me the range, Franco. I'll give you an extra stamp. Rock this one here. Number 6. Give me the range. Don't tell him. Don't tell him.
I'm not paying attention.
No worries. Toscano, say the day. What's the range? Say the day, Clemente. Range.
It's the same thing.
No, wait.
What?
All reals. All reals. All right, here we go. What do you got? You got 7, 8, 9, and 10.
Are we gonna quiz on this or something?
Hold on. Hold on.
Are we gonna quiz you on this?
Oh, hell no.
By the way, this one's a cyclical. This is a trigonometric function. It's going to go like this forever, like that, and like this forever. So just keep that in mind. You and your partner now are going to finish 7, 8, 9, and 10. Whoever wins first gets a free candy. And the 5-year-old one.
Wow.
Hold up.